Welcome. I'm Ryan Black, and I'm going to take you through a little bit of an overview on DAWs, also called digital audio workstations. Today we'll look at the basic structure, some of the things that you will find across many different DAWs, and also give you a list of DAWs that are worth checking out. I will generally use the term DAW. Sometimes you also will hear the term DAW. I just find it a little confusing. So I'll use the actual acronym. In this case, the primary DAW that we use in class is Pro Tools, which is a well-known program that has sort of led the industry for 25 years now, 30 years, as a digital recording system. And still is a leader in the industry, specifically in large-scale systems and places that are specifically aimed at recording and mixing. There are definitely some other players on the market that have really taken advantage of computers and the instruments and other synthesizers and stuff that can be incorporated into creating music and using the computer and a DAW as an instrument itself. And programs like Logic and Ableton definitely come to mind as primary DAWs that people know of and are being used to create amazing work. There are also all sorts of other programs that are more boutique-y and have an edge or something they're doing, whether it's super efficient programming in a program like Reaper, which incorporates well with game engines and other things, but doesn't really allow the massive synth and synthesis manipulation built in to some of those DAWs like Logic or Ableton, FL Studio Pro now in that area as well. So we're going to take a quick look at some of the structures that all of these share. First off, in our class, we're going to be using a naming convention. I have a slide here that's slightly off from what I hope you will use when you submit work, which is instructor initial, which is RB, the section number 0208 11, whatever that is, your last name and your first name, not your initials here, and then the project name. That will allow things to be organized and easily searchable if there are any issues. Going into our DAW workstation, this is a general signal flow of how a audio recording system and DAW work. And a DAW is more than just a computer and a piece of software. And it's important to understand the constituent pieces that make an entire usable DAW. If your interest or your experience thus far is mainly composing and using a DAW to create music, that's awesome, but doesn't necessarily take and make you understand the other steps and pieces that might be involved. So this is just a simple diagram outlining sort of how it works. On the left side, you'll see a microphone, monitor headphones, and monitor speakers. Very common. What's interesting is to consider how do those signals go in and out? And what if you want something different on the headphones than you want on the mix? For example, if I'm an engineer and I'm recording someone else, they might, if say they're doing a voiceover, they might just want to hear another piece of dialogue to cue their voiceover, but not the music. But if I'm mixing, I might want to hear the music and their voice and the other person's voice and the sound effects bed. So how do we do that? How do we route that? Most modern DAWs will allow you to do this. And even some of the interfaces, which is this next step, allow you to do this completely divorced from the actual recording software that you might be using. Here in the audio interface, we have a system that allows us to route. Sometimes it's software controlled, and that's becoming very, very popular now. And the range of price points for a audio interface and how many physical components are involved goes from literally $30 no-name brands you can find all the way up to thousands of dollars and different components for each of those steps. But here are a couple of the primary components you will find in most audio interfaces. First off is preamps. A basic audio interface, 2 in, 2 out, would have 2 preamps, which would allow you to bring your microphone level up to a line level. And then they would also have 2 outputs, stereo output, left and right. And those, this would be the most basic way. Many also have headphone amps and so forth, but that would allow you to connect a pair of speakers, and those would be line level. So an interface will allow signals to come in, will allow you to physically adjust those signals in the analog domain, and will allow signals to go out in the analog domain. Now, after the analog domain of the incoming signals, an interface will often have a analog to digital converter. And you can see that here in our diagram, the ADC. The ADC is controlled by a small computer and often also software now, and that sends a digital signal into your computer and your software. Then with our software, we manipulate, we play with it, we do whatever we're going to do, and we send a digital signal back to the interface, and that digital signal is then converted to an analog signal and sent out to our speakers or our headphones. And that's a digital to analog converter. So an interface will have an analog front end, an analog to digital converter, a digital input signal coming back from the computer, and a digital to analog converter. Often it will also have volume controls, gain controls, etc. for those various devices. The computer obviously handles all of that incoming digital data and then sends out the other digital data, and it also runs the signal processing and the plugins and the software and the algorithms that take various digital signals, audio, and put them together. That algorithm matters. Different DAWs sound different because of how they handle all of those systems. Different DAWs also are more or less processor intensive because of how they handle that data. And that is definitely something to be concerned with, depending on what type of computer, what graphics card, or graphics usually aren't an issue, but what central processing unit you have and how much processing your computer will do. And there are plugin manufacturers that also offload some of that processing to external devices, something that Pro Tools was very early on did, with Avid also doing for video work before they bought DigiDesign and thus Pro Tools. The computer obviously also allows you a graphical interface, a screen, which you can manipulate with your mouse and keyboard to do all of that editing, and connecting of peripherals, which would be things like hard drives, and then sends it back out. So that's a basic overview of how a digital audio workstation, a DAW, works. Here's a picture of one in action. And on top, obviously, we see our graphic output. We see a screen. Here we have a microphone, and that's, not, in this case, not connected, but it goes into this unit right here, which is a Scarlett 18i20, and that is a audio interface. You might notice this has far more controls than what I described in that last slide. It has 8 inputs, well, 8 analog preamps. It has 10 outputs, but it also has ADAT, which are optical inputs and outputs, as well as a SPDIF input and output. Just ignoring the specific details of what all of that means, essentially, there's a lot going on in the audio interface here, this Scarlett 18i20 by Focusrite. And this is not uncommon of 8-channel interfaces. This would allow you, with just what's right here and one USB cable, to, with the appropriate other cables and microphones and stuff, to record 8 microphones at the same time. So say a drum set would be 4, and a bass and a guitar and a keyboard and a singer, an entire band. And also to send a stereo signal to you as an engineer mixing that, and also to send an additional surround sound mix to a surround speaker setup if you want it, and also to send I think 3 more headphone feeds. It's a lot that goes on in a simple interface. You also have 2 headphone feeds right on the front. So there's a lot going on here, and you could potentially add an additional 8 channels of inputs and outputs with an optical device. A cheap one would be like the Behringer ADA 8200. Below that, you'll see a patch bay, and this is all of the connections that are on the back of this device available to you in the front, which sometimes is very useful when you want to switch things up really fast and get to it. Often, if you have a system that's kind of already set up, the patch bay is just an extra step. But if you understand how it works and you understand signal flow, this becomes the way that a studio and a DAW setup can be extremely flexible. Of course, we also see our main computer here, in this case, a Mac Mini, and then we would actually listen by plugging our headphones into this after that digital to analog conversion. There's just a little close-up. You can kind of see it has the first 2 inputs on the front, and these are combo jacks where you could also use a TRS. Each channel has its own gain control here. And then you have some metering, and all of this exists completely outside of the DAW. You can use this device with Mac, with PC, with Ableton, with Pro Tools, with Logic. It doesn't matter. You can just use it. It's an audio interface. It's not the same as a DAW. And then down below that, you'll see this very odd patch bay. I won't go into that, but it's typical, but it has a very weird number of potential input and output points. Now, if we jump over and we look at a specific DAW, in this case, Pro Tools, we will have some tools that will allow us to go through setting up and what you should look through in every DAW. The first thing is every DAW has basic assets and folders where it puts those assets. So in this case, on my machine here, I have a Pro Tools folder. Inside of there are Pro Tools session folders. Each of these, not the zip files, but each of these folders is a session. And within each of these session folders is a session file, which is the actual data of a Pro Tools session, and then other folders that contain various assets affiliated with that session. So when you open a session file, it references only this set of data inside of the session folder, unless you tell it to reference something else. The times when we generally would tell it to reference some other file is when we're working on a large integrated server-based audio system, like for a movie, where we have 3 or 4 people that are doing sound effects for different areas of a movie, and they all need to access the same hard drives to get sound effects, right? We don't necessarily want them to copy, 20,000 gigabytes of sound effects across 3 different computers. We'll set up a server for that so they all can access it and pull. And when they run their Pro Tools sessions, it will look at that and potentially pull whatever files it needs. This is generally not the setup in a home studio. The other place that even in a home studio we'll often use this is for video files, which can be rather large. So if someone sends me a video session, or I'm working on one, also I will often make sure the client has a video on their machine. And when I send the session to that person, I will not send them the video. They already have it. And that really increases transfer speed and stuff. But this set of data exists in every DAW. Pro Tools does a very clear job of organizing these folders and adding new folders as needed. When you open a session, it will add auto backup folders and stuff. And as long as you set it up that way, it can do that. Some other programs are a little more sloppy, where everything just sort of ends up and you have this huge set of files in here. In this case, this does have a lot of files in the audio files, and all of these are used in this session. And then my bounced file is the output from that DAW, and it's right there. So if I'm looking for this riser session and I want different files from it, I can find them. That's the folder hierarchy. Key terms there: session folder, session file. Not the same thing, have to be kept organized. When you start a session, and in general, some things that you definitely want to look for are the sample rate and the bit depth. Generally, 24-bit and 44.1 thousand hertz as your bit depth and sample rate are acceptable and professional. If you're working with video, you often will use 48,000 hertz or kilohertz. The main file types we used are uncompressed, lossless audio, WAV files, or AIFF files. There are other formats, and you can see that lecture on those formats if you look online in our class shell. Once you have a session set up, I will switch over to a Pro Tools session here. Once you have a session set up, in Pro Tools at least, it comes up blank. You just see a gray screen, right? I'm just showing you a small piece of it. But we can very quickly add new tracks with the new track dialog, which is Shift Command N. And you can add mono, stereo, audio tracks, aux tracks, all of these, and almost all of these are available in many other DAWs. So I encourage you to take some time and check these out, see if you find something useful there for your project. And then you hit create. So if I want to create 5 mono audio tracks and a stereo master fader, there's keyboard shortcuts to adjust these, I can create that, and it will come up in my session like that. And here's my mono audio tracks, and here's my stereo master track. Make sure you name things at the beginning. So the last thing I wanted to jump over to and talk about were a couple of the other DAWs that you should know about. Pro Tools, Logic, I mentioned Ableton and FL Studio earlier, but there are also Cubase, which is connected to Nuendo. It's like the little brother of Nuendo. Studio One, which is a PreSonus software that is been around for years and is a great recording software. Some really nice plugins. Digital Performer is the software and DAW that is created by Motu, which stands for Mark of the Unicorn. Samplitude is a German DAW that has some really unique features that I've found sounds really good for recording. It also there's also Sequoia, which is connected to that. And then Reaper, which is the interesting option I mentioned earlier. There are also some ones that are worth checking out, but maybe aren't quite as common in the professional sphere, and those are listed here. All of these can be found in the assignment for week 1. So go ahead and check that out. Enjoy, do some research, read about the different DAWs and what might be the best option for you. I hope that a basic overview of especially that second slide with the input devices, audio interface, computer, peripherals, hard drive, screen, so forth, and then back to the interface to your headphones made sense. That's key to every DAW. And with that, talk to you soon.